Hello everyone. Our lesson today is lesson 2 in unit 4, which is vectors. First, we will talk about position vector. From its name, position, as we studied in trigonometry in the last term, position, it means we have here the origin point. Okay, we start from the origin point in orthogonal coordinates. So the position vector of a point A, here we have point A, position vector of point A is the directed line segment OA, which is the starting point, as we said, is the origin point, and its ending point is the point A. So we said here we have the vector OA, and OA equals here the distance between OA, as we said in third preparatory distance, it means here we have rule of the distance equals square root x2 minus x1 all to the power 2 plus y2 minus y1 all to the power 2. Here we talk about x1 and y1, and origin point is 0 and 0. So by logic here, if we said x2 minus x1, it will be x, and y2 minus y1 here 0, it will be y. So here OA vector equals vector A minus vector the origin point. Okay, so it will be the vector A. So here if we talk about all in general, all position vectors have the same starting point, and we denoted the position vector by the symbol. Like if we said OB vector, it means B vector. If we said OC vectors, it means C vector, and so on. Okay? Here, if we draw a perpendicular, so we have here right angled triangle. Here we have X, and here Y. And OA here is hypotenuse. Here we want to get the length of the vector OA. The length here we called it the norm of the vector. We said in the previous lesson, in lesson 1, the length is the norm. So the norm of the vector is the length of the line segment. Okay, and we denoted the norm by two line segment like this. Okay, here is the norm of the vector A. So from Pythagoras theorem, the norm of vector A equals what? Here the norm of vector A power 2 equals x power 2 plus y power 2. Okay, x power 2 plus y power 2 from Pythagoras. So if we want to get the norm of vector A, so remove power 2 and take the square root. So the norm of vector A equals square root of x power 2 plus y power 2. And let's remember our trigonometric identities. Here we have angle theta. So here sine theta equals what? Equals opposite over hypotenuse. So if we talk about sine theta equals opposite, which is y, over hypotenuse, which is norm of vector A. And if we talk about cosine theta, adjacent over hypotenuse, adjacent here is x, over hypotenuse, norm of vector A. Cross multiplication here to get the value of x and y. Here, of course, sine theta or cosine theta is over 1. So x times 1 equals x. So x here equals norm vector A times cosine theta. And also y equals norm vector A but times sine theta. Okay? And finally, we talk about tan theta equals y over x, which is sine theta over cosine theta. Okay. Here, as we said, the norm of the vector is the length of the line segment, okay? And we said the norm of vector A equals the square root of x power 2 plus y power 2. For example, we have here vector A is 3 and negative 4. So the norm of vector A equals what? As we said in the rule, x power 2 plus y power 2. Substitute under the square root. Substitution. Here 3 power 2 plus negative 4 all power 2. Using your calculator, here we have the norm of vector A equals 5 length unit. Okay, as we said, the norm is the length. Here the unit vector, what the meaning of the unit vector? It's a vector whose norm is unity. What the meaning of unity? Equals 1. Here the norm of A equals 1. For example, here vector A is 3 over 5 to 4 over 5. So the norm of vector A equals what? Substitution, x power 2, 3 over 5 power 2. Plus y power 2, 4 over 5 power 2. Using your calculator equals 1. So here the norm of vector A is equals 1 length unit, okay, which is the unit vector. Here 0 vector, from its name, it's a vector whose norm equals 0. Here the norm of 0 vector is 0, and we denoted by 0 vector as 0 to 0. And here we don't have direction, okay? The polar form, here we write the vector in the polar form. What the meaning of polar form? First, here we write the norm of vector A or B or C as we have, and theta. For example, here we have here A. The norm of OA here is, for example, 6 length unit, and here we have 30 degree. So here we write the vector OA, or the vector A here will be the norm of A equals 6, and the theta here is 30 degree. Here in degree measure, if we talk about the radian measure, it will be 6 and pi over 6. Okay? Finally, the fundamental form. We write the vector in the fundamental form: x times I vector plus y times j vector. For example, here find the coordinates of the point A, where OA, as we said, OA here, it means the vector A. Okay, 10 root 3 and 60. Here the vector A is in the polar form. So here, as we said, here we have x equals what? The norm of vector A times cosine theta, and y equals the norm of vector A times sine theta, okay, by substitution. Here, so x here equals here the norm of vector A, and here is the theta. So the norm of vector A equals 10 root 3 cosine 60. Using your calculator, the result will be 5 root 3. And to get y, here y equals what? 10 root 3 sine 60. Using your calculator, the result will be 15. So the coordinates of A equals, start from x, 5 root 3 and 15. Another example. Here, find the polar form of OA vector, which is OA vector is 5 root 3 and negative 5. Here, polar form, it means here we have the norm of vector A and theta. So first we want to get the norm of vector A, or the norm of vector OA. So here the norm of vector A equals square root x power 2 plus y power 2. Substitution. Here x equals 5 root 3 all to the power 2 plus negative 5 all power 2. So we get 10 length unit. So here the norm of vector A is 10 length unit. We want to get theta. How to get theta? By using trigonometric identities. Tan, as we said here, we have rule of tan theta equals what? Equals y over x. Y here equals negative 5 over 5 root 3. It means negative 1 over root 3. So we search for the measure of an acute angle whose tan equals 1 over root 3. Don't we search for the positive angle, the acute angle, whose tan is 1 over root 3. So we press in your calculator shift tan 1 over root 3. So we have the angle 30 degree. Okay, so here we have the acute angle is 30 degree. Stop here. Here remember Aztec rule. Here Aztec rule. In the first coordinate, all are positive. In the second, sine and its reciprocal, cosec, is positive. In the third quad, tan and cotan is positive. In the fourth quad, cosine and its reciprocal set are positive. Okay, so here, as we said, 180 minus theta, here 180 plus theta, and finally 360 minus theta. Here, if we looked for OA here, x is positive, so here x greater than 0. And y negative, so y less than 0. So we talk about the fourth quad. X positive and y negative. Okay, so here theta will be 360 minus the acute angle, which is 30 degree. So here we have 330 degree. So OA vector in the polar form will be here the norm of A will be 10 and theta will be 330 degrees. The last example. Express the following vectors in terms of the fundamental form, then find its norm. As we said, fundamental form, it means x times I vector plus y times j vector. So here A vector equals negative 8 I vector plus 6 j vector. Okay, and then find its norm. So the norm of vector A equals x power 2 plus y power 2 under the square root substitution. So here negative 8 all power 2 plus 6 power 2 equals what? Equals 10 length unit. So the norm of vector A is 10 length unit. Okay, thank you.